see a lot of mathy, kind of mathematical lingo, but this is basically saying any like polynomial to any degree n, we define as a polynomial. So this is just the generic setup of a polynomial. All right, so for example, you might have like, I don't know, 4x to the 10th power plus x4 minus 2. Okay, 10th power, we just call it a polynomial. You don't have to worry about binomial, trinomial, just polynomial, any number degree. You could have, I'm just making these up, you don't have to write them, but just giving you some examples, maybe -2. So that'd be another one. This third degree, just a different one. Polynomial functions, they are whole numbers for their degrees, and it's not a polynomial function if the degree is a fraction or a negative number. So over here, we notice we got like, it's the second term. We got the square root of 2, but is this x squared under the square root here? It's not. So simple fact that the number is under the square root is okay, but if we go over here, this isn't a polynomial function because we got the square root of the variable x. So your variable can't be under a radical. That would not be a polynomial function. It's not going to be predictable in terms of what it's doing. So we would say that this is a no. Another way you would write that square root is like having your exponent to be 1 over 2. We talked about that when you have a fraction in your exponent. The bottom number is the index, the top number is the power. That will not be 1. Another one that isn't here, but like if you had x to the -2 power, this would not be a polynomial function because this really is 1 over x squared. Remember we talked about that shift when you change the sign of your exponent? We talked about that a while ago. This would be a no as well. All right, so these polynomial functions, we look for the degree to be, where we say n is the degree, we need that to be greater than 1. All right, and it's got to be a whole number. We might write that as well. Let's see, a whole number. We need whole numbers, positive whole numbers. Then we can say it's a polynomial function. And when we confirm that it's a polynomial function, it's got 2 distinct features. When we start looking at these graphs, polynomial functions are smooth and continuous. Polynomial functions are smooth and continuous. All right, by smooth, we mean that the graph only has rounded curves. So for instance, this one right here is a polynomial function. It's pretty smooth. It turns and changes directions, but everything's curvy. It doesn't have any like sharp edges like this one right here where you got a sharp corner and then it jumps and does something else. It's smooth and continuous. Does smooth make sense? Like a road. It's nice and smooth, not a sharp turn, smooth, and then continuous. We talked about this with the piecewise functions. Continuous, I can take my pencil, go over the function, and I don't have to pick it up and go somewhere else. So see, it cuts off right here. My function isn't continuous after this point. I got to jump and go somewhere else. So this one to the left is smooth, and it's also continuous. I don't have to stop and go somewhere else. So these would not be polynomial functions. This one would be a polynomial function. Smooth and it's continuous. Those are the 2 key features. Okay, when we do have this though, we can find some key things about it, and there is some consistencies about these that we'll identify. All right, so over here to the right, like we say, this is your generic setup for your polynomial functions. The key thing we'll focus on is the leading term. And you'll know this is the lead term because it'll be to the highest degree. So this setup just means, let's say this n was 8. So it was x to the 8th power. What would 8 minus 1 be? 8 minus 1. 7. So you can insert, I know they went to math, especially when I talk sometimes. So this just says basically you go in descending order. 8 minus 1 is 7. Then next you would have 6. And you would keep going until you got to just x, and then it might be plus or minus the number 1. So this setup just, whatever your highest one is, 6. Well, then you just go backwards from that. So next would be 5, 4, 3, 2, 1, and then your number. If it was 20, the next term would be what? 19, 20 minus 1, and then you just keep going down, descending order, until you got to just your number. This is what this means. It's just a generic setup for your polynomial functions. All right? So we need to know two things to be able to determine what's happening as the function goes to the left and to the right. So for instance, when we go to the left side, this graph is going up, right? So for this one, we can say it's rising to the left. As we go to the right, is it falling down or is it rising to the right? Rising. It's rising to the right. Now, we can look at a graph and see this, but we're going to be able to just look at these functions, and you'll be able to tell me that just from looking at the function. You don't even need to see the graph. We're going to identify just from looking at the function. So the two things we're going to look at is the degree, which is the highest like term in terms of the exponents. It's the highest number you see. That'll be the degree of the whole function. And then the leading coefficient, or the leading number. That's going to tell me whether it goes like up or down. This is all we need to know to determine the end behavior as the function goes towards infinity in either direction. All right, so let's come down and look at a problem, and then we'll like put the pieces together. We'll go backwards and see how you kind of use this chart. It's real easy. It's not complicated at all. All right. So we come down here and we look at this polynomial. We got x cubed plus 3x squared minus x minus 3. All right, okay. And first we need to determine the degree of this polynomial. The degree is the highest power number that you see, even if it's out of order. It won't always necessarily be the first one, because it can be written out of order, but you look for the highest like number in terms of your exponent. What's the highest degree like exponent you see here? Cubed. So that would be my degree for my function. The degree would be 3. Everybody okay why we went with 3? That's like the highest number exponent. Is 3 even or odd? Odd. It's an odd number. Now, the simple fact that the degree is odd will tell me something about the ends. Knowing that my degree is odd, I can go ahead and tell you the ends are going to be going in opposite directions. It's either going to be kind of like an uphill graph where it falls to the left and rises to the right, or it'll be like a downhill graph where it rises left and it falls right. We got to determine which one of these two it is, because we've already determined that n, the degree, is odd. We can write that just to make sense of it. Is an odd number. It's one of these two. How do you think we're going to determine if it's falls left, rises right, or vice versa? Because one of them looks uphill. Go ahead. Yes. What kind of numbers are less than 0? What kind of numbers are greater than 0? So we look at the leading coefficient, and we need to know if it's positive or negative. So nothing's here. I don't see a number here, but what's understood to be here? 1. Is it positive or negative 1? Positive. So the leading coefficient is positive. Odd positive is greater than 0. So I can go ahead and tell you it's going to fall left, rise to the right. All right, we got an odd degree. That tells me it's one of these two. Since it's positive, it'll fall left, rise right. Kinda makes sense. Let's do the one below. All right. What's the degree of this one? 4. We're looking at the exponent. So the exponent 4, that's the largest exponent I see. Degree is 4. Is 4 an even or odd number? So it's even. Okay? So I go and look at my graphs. It's got to be one of these two because the degree is even. And like I say, if you want to write that just to tell yourself that, even number. So when it's even, the ends go in the same direction. Either rise, rise, or fall, fall. Everybody okay with our two options because it's even? All right. Which one do you think we're going to go with? Falls, falls? Well, what kind of numbers usually will make it fall? Negative. What's the leading coefficient here? Positive 1. So it's positive when your leading coefficient A is greater than 0, or if it's positive, it's going to rise, rise. Okay, so we're going with this one. Rises to the left, also rises to the right. So rises left, rises right. Okay, let's talk about this one real quick. I'm just making this one up before we move on. All right, what's the degree? 5, okay. 5 even or odd? Odd, so I know the ends are going to be going opposite directions, right? Either like this or like this. You said falls which way?
Falls left, rises right. Or am I mixing the rises left, falls right?
Yeah. Is the leading number negative or positive?
Negative.
Negative. So odd, negative, what's it doing to the left? Rising left, falling right. Odd degree, 5 is odd. Negative leading exponent, it's doing this. I don't know what's happening in the middle, but I can tell you the ends will be rising to the left, falling to the right. Does that make sense? Let's do one more. All right. What's the degree?
3.
But 2 comes first.
The 3's bigger.
3 is bigger. It's not in descending order. The correct order should be so now when we write it in order, we see it's this one. Do you have to write it in order? No. Just understand this is the term that you care about because it's got the bigger exponent, the biggest exponent. That makes sense? So the degree is 3. Is 3 even or odd? So it's got to be one of these two on the right. The leading coefficient, is it positive or negative?
Negative.
So what's it doing to the left?
Right.
And to the right it is?
Falling.
All right, you see how this works? So now you probably just need to know if the degree is odd, the ends are opposite. Like this, look like I'm doing the disco. It's like this if it's odd. If the degree is even, they're doing the same thing. Both up. both down. That make sense? All right, let's look at some other cases. What's the degree of this one?
3.
3? Okay, fair enough. Any other guesses? This one right here to the right. Now, what's different about this one and the ones we were doing over here? What do these parentheses mean? Are we adding, subtracting? We're multiplying. So now, not like adding, when I multiply exponents, or when I multiply variables, the exponent's going to get bigger, right?
Yeah.
So this degree probably isn't 3. In fact, I go ahead and tell you it's not 3. It's going to be higher than that. So I'll give you a second, maybe you can look and make a determination of what the degree is. Anybody got any guesses?
It's 6.
It is 6. Yeah, how'd you know that? What made you?
3 times 2.
3 times 2? For the X, we do Nico's shortcut. Add the degrees. Because when you multiply, you add the exponents. 3 plus 2 plus, even though it's not here, 1, which gives me a degree of 6. All right? And then you're multiplying all the other ones by just 1, so this leading coefficient won't change. So you'll know it's going to be -4. That's a lot quicker than having to pull and multiply and distribute. We just look at these lead numbers and we add them to get the degree. Which is 6, and we said 6 is even, right? And then this lead number isn't going to change because it's just times 1 times 1. So the lead number would still be negative.
So it rises up also, right?
Not quite. All right, so everybody okay with it being even 6? Everybody okay with that? And the leading coefficient, is it positive or negative? Negative, so? Positive, sorry, even here. Positive, which one, left or right? Left. What's it doing to the left?
Rising.
What's it doing to the right? Rising.
Isn't it negative?
Yes, but the degree is even. Oh, you're right.
Yeah.
Oh.
Yeah, that's what I was confused by.
It's this one, right? What did I say? I said positive, didn't I?
Yeah.
Why did I say positive? Maybe I was thinking about the degree. All right, so let me back up. I don't want to confuse anybody. 6 is an even number, right? -4 is negative. So it's falling left, falling right. Am I saying that right? Oh, sure? All right, so this is what we got. And look, when in doubt, as you guys write that, let's graph it, because the graph doesn't lie. Let's see if that matches what we're concluding. 4x cubed, then we got x minus 1 squared, then we got x plus 5. I know my window is jacked up, so let me try to fix it. And we'll play around with these at a later point, once we get a good grasp on the basics. Ooh, I need to zoom out a bit, don't I? That's way too much. Let's see, let me get a good window. How about 20, 10. Let's see, we don't need to go that low. Maybe -10, 40. Well, it's very zoomed in, so it's difficult to see. And that's even harder to see. Let's see, let's go zoom standard. Let's see what we got.
It's a really nice graphic.
Oh, thank you. Like I say, the calculator is not very smart, it's talented. And look, it is still thinking. That's not good. I think I broke it. Typed it in right. Let's see, my zoom is standard. All right. So for time's sake, I'm not gonna keep playing. It comes here, it goes up, it comes back down. You see how it's falling to the right and it's falling to the left? That's the point that we need to see. See that? All right. Everybody good? Okay. You guys take a second. Let's take a shot at these three. All right. 3 separate ones. Determine the degree, and then you look at the leading coefficient, look at the sign. Take a second. Let me know if you get stuck. What's the degree of that first one?
6. 5.
Not quite. 3, 1, 1. 5. 1, 1. 3 plus 1 plus 1.
Okay, a few things wrong.
No. Everybody said 6, huh?
That's a 5.
Yeah. 5 is right. All right, then we got it. The first one, top left. What is it doing to the left? Falls left, rises right. Good. What about the one to the right of it? I got rises right, falls left. I wrote it backwards. Why am I being dyslexic today? Hold on. So it's odd and it's negative. Odd, negative, rises to the left, falls to the right. That is correct. Why am I backwards today? All right. Rises left, falls right. So it's kind of downhill. Good with that one? And then we got even, 4th degree, even number, and it's negative, even same direction, falls and falls. Falls and falls. All right. We feeling okay about determining the end behavior? Anybody got any questions? All right. So at this point, For instance, on maybe this one, without even graphing it or thinking too hard, for maybe this one on top, you could go ahead and tell me, oh, so it's going to fall to the left, rise to the right. Now the next question is, what is happening in between these two things? That's another thing we're about to determine. Okay, so kind of like in the do now, where we solved the function, we're going to solve and we're going to find all these x-intercepts. So then we can say, okay, if we find these key points, then we can maybe conclude that the graph is going to go through these. And then we can kind of put in some of the missing pieces. Now we're not going to find all of this, but we're going to find some of these easy x-intercepts where it crosses the x-axis, and then there'll just be more key points we find, all right? So that's what we're doing. All right, over to the left. If you're doing a graphing utility, it's just giving you some things about the window, some of the battles that I was just fighting. We'll spend the day and look at that at some other point, but we got to understand what we're actually finding first before we get there. So we're going to talk about the roots and the zeros. All right, so these have a bunch of different names. They all mean the exact same thing. So when you set your function equal to 0, and you find the different values of x that will make your function equal 0, we call those the zeros of the functions. Right? We also call them the roots of the functions. Maybe in Algebra 2 you've heard or talked about that word roots. All right? Also known as and these are the values of x, also known as the x-intercepts. The x-intercepts of your function. Right, so if I go back to that difficult to read graph I just showed you guys, the roots or the zeros are the points on the graph where your x, where it crosses like the x-axis. So for instance, right here I would have a 0, here at 0 it looks like I have a 0, and then over here at what looks like maybe -6, I've got another 0. These are the zeros of the functions, also known as the roots, also known as the x-intercepts. They all mean the exact same thing. The way you find this is you set your equation equal to 0 and you solve it using those different methods that we did in playing trash ball the other day. Okay? And the real roots of the zeros, the real roots, will be some points we can use to find our graph. And again, we're talking about the x values, the x-intercepts. Okay, these all mean the same thing. When I show you, it'll make a little bit more sense than these definitions. All right, so we got to use these factoring techniques. Let's find the zero. So we're basically solving this function. So we'll take what we got here. You don't have to rewrite it. You may just set it equal to 0. I'll go ahead and rewrite it. So this is my function. To find the roots, we take the function and we set it equal to 0, and we want to solve. And this is where those factoring techniques come in. Do I have a GCF between all 4 terms? Does this one have an x to give me? No. Can I divide everything by 3? Nope, I can't divide these two by 3. GCF is 1. How many terms do I have? 4. Yep, we can try to group it. Let's try to group it. So we'll group the first 2. And we will try to group the last 2. All right, so I don't remember doing one with 0, but not 0, but with the negative, like 3rd term. So just make sure, like, for now, I'm going to keep this term negative, but I'm going to separate it with the addition. So if we remove the addition, like, we get back what we started. So I'm going to leave it like this for now. Everybody okay with why I wrote it like this? It's basically like plus a negative number, because this comes out to be negative there. All right, now, GCF of the first 2. Do I have a common GCF now? Yep, can take out x squared. So I got x squared. What am I leaving behind? Yep, x plus 3. And now I know I want this second grouping to end up being like this. What would I factor out over here? Yeah, because I want these signs to change. If I can get this to be x plus 3, I'll be good. So if I factor out a negative 1, that lets me change the sign. So I'm going to do minus 1. I factor out negative 1, and now I got x plus 3. And I think I'm good to go now. Everybody okay? So I got x plus 3. And then what's my second group? Minus 1. All right, so like I said, this is what we did. This is what we spent Monday doing. Only difference now, I go one step further and I actually solve it. So I take each factor and I set it equal to 0 to solve it. So here I got x plus 3 equals 0. To solve it, I do what to both sides? And I see that x equals negative 3. That's one of my zeros. I go on to the next one. X squared minus 1 equals 0. Add 1. Then I do what to both sides? Yeah. When I take the square root, I got plus or minus. So x equals, negative 1 and positive 1. So in total, I've got how many answers? 3. My zeros are x equals negative 3, negative 1, and positive 1. Everybody okay? Yeah. All right, any questions? So you guys just solved that function. And solving it is finding the zeros. Zeros are roots. These are the x-intercepts. What is the degree of this polynomial that we started with? Well, are we multiplying or just adding? We're just adding. You see plus, you see minus. This is like these ones. We didn't add the exponents or anything. Only time you add the exponents is when it's like these parentheses right here. Oh, so maybe you guys were thinking about this. Well, even if I did that, it would be 1 times 2, which would be 3. Or I just look here, the degree is 3. Everybody good with that? What's the sign of the leading coefficient? Positive. So odd and positive. What's happening to the left? Is it rising or falling? It's odd and it's positive. So like this? Nope. So like that. Now these zeros, we had 3 of them, right? Negative 3, negative 1. What was the last one? Positive 1. All right, so roughly, it's going to go through these 3 x-intercepts. Maybe up, maybe down, and then back up to finish like that. Wow. Is that not amazing? Let's see how close I am. Let's see, we got x cubed plus 3x squared minus x plus 3 minus 3. Ooh, that was loud. Man, I'm not too far off from a graph by hand. That's not too far off. So we said it was odd, so we know the signs are, the ends are going in opposite directions, right? And then it's positive, so it's generally uphill, falls left, falls right, that part makes sense. And then those zeros we just found are where it crosses the x-axis. So -3, -1, +1. Does that make sense? Do you understand what you just found? Which is pretty amazing. Not a lot of people here at the school could do that. That's pretty amazing. All right. You guys got any questions? All right. Let's do the one below. And you guys feel free to kind of work ahead if you think you want to take a shot at it. I'll kind of keep talking through it. So I see 4 terms. I don't have a GCF. Can't combine any like terms. I probably got to group them again, don't I? 4 terms. Let me group them again. X cubed plus 2x squared then I will group second 2 minus 4x minus 8. And I do want to solve it so it will equal 0. You guys see if you can go from here, if you haven't already gone from here. From the first 2, factor out x squared. See, I'm left with the x plus 2. And then I know I want this parentheses to also end up being x plus 2. You probably knew you could factor out 4, but then I got to remember I want to change the signs as well. So I factor out -4. And now I got the same thing, so I group them. X squared minus 4, common factor of x plus 2. We good here? Now I set each factor equal to what? 0, and I solve. Here I got x squared minus 4 equals 0. I add 4, and then I take the square root of both sides, and I get x equals +2 or -2. And then for this one, x equals -2. So what are my zeros? -2 and 2. Do I need to write -2 twice? No, it's 1 0.
Where'd you get -4 from?
Right here.
Okay.
Yeah, this is what we did. You were out Monday. This is what we did. So it's kind of like if you had 2x plus 2. You can't see that. Everyone's eyes, thank you. This better? Okay. These have a common factor of 2, so when you factor it out, you end up with x minus 1. Does that make sense? It's the same concept. Both of these are the common. So these are the 2's. You factor it out, you keep one of them. So that's us factoring it out. Just like here, we factored out 2, which gave 2 right here.
Okay.
So this is my common factor. So we factored out, and we get to keep one of them. But then you have to see what we left behind. We left x squared, and we left minus 4 behind. So they have to stay. If I wanted to get back to where I started, I could do x squared times that, and then I could do x squared, negative 4 times that, and I would get back to this step. So this was a common factor. This is factoring by group, and this is what we did on Monday. And it was just another method of factoring.
So what I'm doing is I'm just taking one of the ones out of the brackets, or am I taking both of them out of the bracket?
Where you're taking 1 from each term.
Oh, okay.
So each term had 1 to give. So basically, like, if I did something else, let's say it was 2 times 2x plus 2 times 3. Well, they both have a 1, 2 you can take out. So you take that 1, 2 out, and now you got 2 times 2x plus 3. Because we took 1 out.
Yeah.
1 out from each one.
And then what do we do with that? Do we just plug that
This.
in? The 2 that we left out?
This one?
Yeah.
Well, if you wanted to get back to here, you can distribute it. But we want to factor.
But then why did you put it into the equation? Why didn't you have x squared minus 4?
Are we
That's
here?
That's what I was asking.
Here?
Yeah.
Why did I go here?
Yeah.
Because that's how you solve it. You solve it by setting each factor equal to 0. So then we had to factor first, and now we can solve it because we know what the factors are.
Yeah.
So one factor set equal to 0, the other factor set equal to 0, and you get all your answers. It's the same thing you did up there. All right, one last one. All right, how are we starting this one? Any ideas? How many terms? Okay. I have a GCF? Yep, x squared. So I can factor out x squared. Good job. Now, I'm thinking 3 terms. I'm probably going to put it in the parentheses, right? Like fully. But I probably don't want to factor a negative x squared. So why not go ahead and take out negative x squared? And that way, in this first position, what do I have left? Yep, positive x squared, which will be more easier to factor. I would rather factor this. What is the next term? Yep, is it minus or plus? Well, we factored because we got it's minus because we took out the negative, meaning basically we're going to change the sign. So minus 4x. Then what's last? Plus 4. And you can always check, distribute it back, you should get what you started with. That would make this negative, that would make this positive, that would make this negative. So yep, I think I'll get back to where I started. Everybody good? 3 terms, trinomial. I think I factored this by putting it in, like unfolding it, right? What goes in those first positions? X and X. And then I need 2 numbers that I multiply to give me 4. Yep, because when I put 2 and 2 together, I get the middle number, negative 4, right? 2 and 2. 2 times 2 is this number. What do the signs need to be? The same or different? Same. Because when you multiply, you get a positive number. They either both have to be negative or both have to be positive. We chose negative, why?
Because if you multiply -2 and -2, you get 4.
But I could have did positive to get positive 4. I could have did positive. How do I know negative is what I need, though?
Because if you have -2 and -2 together, you get -4.
Yeah, the middle number, when I put them together, is negative. That's how I knew they needed to be negative. Everybody good? Because it will be -2 minus 2, -4. Now I take each factor and I do what? Set it equal. Negative x squared equals 0. I divide both sides by negative 1. X squared equals 0. How many times does x squared equal 0? Square root both sides. Twice. That'll be important in a second. We'll come back to that. So when I take the square root of both sides, it'll be plus or minus 0. Which means I got that answer twice. Okay? My next one, I got x minus 2 equals 0. Add 2 to both sides, I get x equals 2. Now, do I need to do that again? X will still be 2. But I get this answer how many times? Twice. That's going to be important in a second. All right, so in total, I just got 2 zeros. X equals 0, 2. Let's see, let me graph this. Do I want to graph this one? Let's go back one and then we'll graph it. Anybody got any questions? All right, I'll do that. I'm going to set up the graph for the previous one we did, checkpoint number 5. We got x cubed plus 2x squared minus 4x minus 8. All right. So let's backtrack. Let's see if we can maybe sketch this graph real quick. Or you can help me sketch it. We'll look at the key points. All right. So what's this degree?
80
Positive 3. So it's odd, right? That means the ends will be opposite. Either like this or like this. Which one? Like uphill? So, like this?
So I think last ball is right. No, other way.
Is this uphill for you?
Yeah.
Like uphill? So it falls to the left, rises to the right. Correct?
I could figure it out.
Well, positive, oh, this one, it could be down here if you're backwards, but you're not backwards, I'm backwards, hopefully. All right, so that would tell me okay, then I look at my zeros, all the negative 2 and 2. That's it, right? Now, what's going to happen here is this. Let me see, let me show you my graph. All right. We had negative 2 and positive 2, right? What's different at these two zeros? What's happening differently with the graph? And mine, just for FY, mine looks pretty close, doesn't it? It's not bad. What's different from this point and this point? Does it go up?
No.
It touches it and turns, right? But at this one, it goes through. How many times did we get negative 2 on this 4-0? Twice. How many times did we get 2? That's the difference. Okay? 2, that's an even number, right? That's called the multiplicity, which is the last piece of the puzzle. The multiplicity is how many times you get an answer. So on this problem right here, we got negative 2 twice. That would make the multiplicity even. When you have an even multiplicity, it's only going to touch the graph. It's only going to touch that 0. And it'll turn around. So notice here it touches and it turns around. When the multiplicity is odd, 1 time is an odd number, it's going to cross. See the difference between the two?
Yeah.
All right, that's the last piece of the puzzle. How many times do we get that as an answer? If it's an even number of times, then you know it's going to touch and turn around. If it's an odd number of times, then it's actually going to cross at that value. Let's finish up. All right, so sometimes you'll get some where the work's already been done for you and it's already factored. Don't start multiplying. That would be taking you backwards. Just go ahead and set your factors equal to 0. This, we already got a factor. I take my factors, set them equal to 0. It's the first one, x squared equals 0. I take the square root of both sides and I get plus or minus 0. We're okay with that?
Yeah.
Next factor, x minus 2 on this one, equals 0. X equals 2. How many times did I get 2 as an answer?
Twice.
Yeah, because this is like this. Where is it at? This. But it's no point in doing it twice. I just know I'm going to get this 2 times. So the multiplicity here would be 2, which is even. How many times do we get 0 as an answer?
2, 2, 1.
Twice. I mean, negative 0, it doesn't matter. It's still 0, 0, 0. So this multiplicity is also even. So I can tell you at both of these, it's going to touch, but not turn and cross the graph. Let me graph this one right quick and then we'll keep it moving. So I got x squared and then x, not x squared, x minus 2 squared. All right, so notice, 1 was at 0. It didn't cross, did it? Didn't cross. It touched and it turned. Here at 2, it touched and it turned. It didn't cross. What's the degree of this?
2.
What was multiplication? So 2 plus 2. 4. I know the ends will be going the same direction, right? It's positive. Rises left, rises right. Is this all kind of clicking together?
Yeah.
A little bit? Okay, so what we said is, you see how many times you get an answer. If you get it an even number of times, the multiplicity is even, 2, 4, 6, 8 times. And then it's going to touch, or I should say it touches the x-axis, and then it goes back in the direction it was coming from. If you get a 0 an odd number of times, the multiplicity is odd, and it will actually cross the x-axis at that 0. So there it crosses. All right. All right. So let's go over here to the left. So this is already factored for us. Thank God. We just take each factor and do what? To solve it. Set it equal to 0. Okay, so first one, 1/2 equals 0. This is just like a scalar multiple. It's just a number that we multiplied the function by, and it was a GCF. So when you get like just a number in front, you don't worry about that. You don't even have to like set it up like this, but the 1/2 doesn't really affect where the zeros are, so we just keep it moving from the 1/2. So I do have x plus 1. I set that equal to 0, and I got 2x minus 3 also equals 0. Subtract 1 from both sides on this one. X equals negative 1. How many times do we have this factor? Do you see an exponent? Once. So we got it an odd number of times, right? Multiplicity is odd, which means it's going to do what here?
It's going to cut.
Crosses. Multiplicity is odd, is going to cross. So here it crosses the x-axis. If that makes sense? Here I add 3. Then I do what? Yep. Divide by 2. 3 over 2. How many times do we get this answer? Twice. So the multiplicity is an even, which means So we got this 2 times, multiplicity is even. That means it touches and it goes back. All right. All right, let's do one last one. No questions? All right, already factored, nice. I set each factor equal to 0. The first number, that's just like a vertical, it's almost like a vertical stretch. It doesn't change where the zeros are, it just stretches it. So you don't worry about that. I take the other factors that have the variables with them though, and I set it equal to 0. Okay, here I subtract 1/2. How many times do we get this one as an answer? Twice. So even, which means touches, right?
Yeah.
But it won't cross. Just touches the x-axis, turns. Here I add 5. And we got this one how many times? 3, which is odd. So I know it's going to cross the x-axis here.